Hello everyone, it's November 29th. I gave this problem another thought. I think I know the right solution. It should be prefix exclusive OR. Yeah, well, we'll try that one again. It should be prefix exclusive OR. I think so. Alright, make sum divisible by p. Oh, is this one hard? I wonder. Given an array of positive integer nums, remove the smallest subarray such that the sum of the remaining elements are divisible by p. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1 if it's not possible. A subarray, blah blah blah. Okay, so what we need is to remove a smallest subarray. So the total sum is 10, and we need to remove the smallest subarray such that it's divisible. So as 1, I remove 4. Okay, yeah, remove. This is remove nothing because it's original. Okay, so we will definitely add them up, and if it's divisible, perfect. And then we want to find the smallest subarray. Once removed, it's divisible. Let me think. So we have the total, and if we do mod, right, 10 mod 6 is 4. So to remove something, we need something that has mod equal to 4, right? It has to be, because you're removing those, so the remainder has to equal to this remainder. So yeah, it has to be the same, 4. So the question is, what is the smallest subarray whose remainder is equal to this? So if we do a prefix sum, right? So 3, 4, 8, 10. And then we take mod of 6. 3, 4, 2, 4. Right? What does this mean? This just means, and what we need to find is a subarray, which is this minus this. That's like anything minus another thing. Right? So what we need to find is a subarray. So like this is 3, it can only by itself. This can be this or this, right? So if we get a 0 at the beginning, okay, so probably will make things a little bit easier. So what we want to do is for each one minus any one in the front, such that, so if I have this value, this p sum I minus some p sum j, such that j is smaller than I, and we want this plus p mod p is equal to 4 in this case. So in other words, if I know what this value is, if I know this is 4, so we want to have something is 4. So basically, say like something minus this p sum j, right, plus p mod p equal to 4. So what this has to be, like if I know this value, can I know this value? I think the answer is yes. So if you are 4, then you need to minus 0. Right, if you are, so yeah, if you are 1, so 1 minus something to be equal to 4. So we can actually just 1 plus 6, right? So it's 7, so 1 needs to be minus 3. So 1 minus 3, yeah, 1 minus 3 plus 6, right? So it's just plus 6, everybody plus 6, and then minus this 4. So there's 3 plus 3 minus 4, so this requires, we're looking for 2. All right, we're looking for 2, because if this minus 2, which is 1, why 2? No, it's 3 plus 6 is 9, minus 4 is 5. This is 5, right? Why can't we do 3? No, because what we're looking for is the mod has equal to 4, right? The mod has equal to 4. So if this is smaller than 4, then you have the plus 6 minus 4. So this need to look for 0. This need to look for plus 6 is 8. So this needs to look for 4. This need to look for 0, right? So I know who to look for. So this is no 5. So this is not possible. This is 0. So this length is 2. This is 4. Length is 1. This is 0. Length is 4. So that's what we're gonna do. So we get a sum. We get this. We do a prefix sum. We get we put the latest of this appearing, right? And then when you count, so it's gonna be an array with the latest appearance. So latest, right, appearance, and every time we hit something, we look into here, we get, okay, yeah, that shall do. One 590. Prefix sum and get the modulo. For each presum value, we want to find the latest modulo. Get the remainder. Right, the remainder, latest remainder that can allow it to create a subarray. Create a subarray whose remainder remainder of the sum is equal to the remainder of the entire thing, of the sum of the entire array. I don't think I'd explain it very well, but you will know. So int s is 0, so for n of nums s equal to, actually this is, call it r. Okay, r plus n mod p. Okay, so this r is the total. Now what we need to do is std vector latest of nums size. This is the latest, okay. Latest index of, oh, that's not true. Oh, depends on the value. So we might need to have the max value, max val. So that max val can help me decide what this is going to be. So we'll use this opportunity. Okay, let's say max val, max n, max val. Okay, so here the latest is gonna be max val plus 1, latest index of a value in nums. Okay, so this is important. And then prefix, that's fine. And we need index. 0 is going to be 0, right? 0 is going to be 0. So int rest is going to be, we remove the total length, which is not allowed. So we will set to this, okay? And for int I equal to 1, I smaller equal to nums.size, I plus plus. Now what we're going to do is we have a prefix. We have r, so we need to say p sum, right? Equal to 0. P, no, pre-r. Pre-r plus nums I minus 1 mod p. Okay, so now what we're gonna do is we're gonna look for I think we should be -1, everybody. Okay, -1, and then latest 0 shall equal to 0. Okay, so int target r shall be pre-r plus 6 minus p plus 6 plus plus p minus r mod p. This is our target, right? This is our target. And then we say if target r latest, right? Target r is smaller than 0. If it's larger equal to 0. And then what we do is we say res shall equal to cd min res I minus latest target remainder, and then latest prefix r, I go prefix r, okay, prefix r. So this prefix r equal to I minus 1 actually. Ooh, is it I or I minus 1? It's I. Yeah, it's gonna be I. So we have a 0 at that position. So if it's large equal to 0, that means we have handled it already, so we can do it. And then I'll update it. And at the end, we'll return res. All right, let's give this a run. Oh, it's based on, it's not based on the max value. My bad. Yeah, that was a it's not this. We don't need this. Has nothing to do with it because the latest, this is p. Okay, it's dependent on p because everybody is mod p, and then 0 is going to be 0. Oh, we shall say res is equal to nums dot size. If it is, then -1, otherwise will be res. Okay, let's try it again. The last one. We never get to a 0. Why? So R is 0, right? If R is 0, 1, 2, 0. So 1 doesn't have. 2, no, 1, 0, 0. So this, yeah, also the minimum is removing 1. So, okay, here. If R is equal to 0, then we'll return 0. So this is no need to remove anything. Okay, I'll run it. This is interesting. Memory. Is it because of P? It's because of P. Okay, so we don't do this. We say std unordered map int latest. Okay. Yeah, I'm not sure if it's going to work, but we'll look at it. So 0, 0, and then blah blah if latest dot contains t target r, then we do this. At. Okay, if it contains, then we do it. If it doesn't contain, we'll just do this. Alright, let's give this a run. See if a map will make it work. Does a map work? Oh, map seems to work. Let's see if it works. It works. Map make it work. Map makes it work. Alright, let's see the previous. We have a runtime error, which I don't even know. I think we're doing about the same thing. No need to remove. Yeah, I think we're doing about the same thing. But I have to do it again. What about this memory? I think we got stuck on the exact same thing. And then I decided, you know what? Screw that. We are going to use a map. Yeah, we're using a map. That was 2024, about a year ago. I'm surprised that Java is actually faster. Huh. Very interesting. Is that the same number of test cases? Um, 145. 142. We added new test cases in this one. But I think it still works. Solutions, editorial, brute force, not gonna work. Prefix sum modulo is going to work. Blah blah blah. Yeah, we use the map. Get a total sum, get this. Current, needed. Yep, it's exactly the same. It's almost carbon copy. The only difference is I use contains and I use at. That's the only difference. I want to know what I put. I say good interview question. Yeah, maybe. Alright, that's this one, and I want to revisit this one. We have about 10 more minutes. I do believe we can revisit this, and I will delete everything I did yesterday, which is, you know, it just doesn't work. Alright, so new idea. We will use prefix exclusive OR, right? For a subarray to have exclusive OR equal 0, we must have prefix exclusive OR I equal to prefix exclusive OR j. To have a subarray nums j plus 1 to I plus 1, right? So what we do, so we keep track of the indices, right? For each prefix exclusive OR, and when for a new pref exclusive I, we go through the list we go through the previous indices from small to large, okay, and find one, and find the first index, right? First index that allows us to have an even, right? To have an even length, subarray length. And if this length is bigger, right, than the current result, we use that. If it is smaller, we skip, right? This might run in O(n) squared, but we will see. This should run, right? This should run in O(n), but in reality, real practice, it might be better in performance. Anyway, I'm not sure. So what we gotta do is get a prefix exclusive OR with the same length. In fact, I think I'm gonna do a n plus 1. Alright, so for int 0 I smaller than n, I plus plus, we are going to do prefix OR, but actually we don't really, this is not what we want, right? We don't want prefix OR. What we want is an ordered map this is going to be a vector of int, right? And then we call it exclusive positions. Okay, so we have int pxor. Okay, and then the thing we do is we'll first say pxor exclusive equal to nums I, right? And then we're gonna look for, we also need a result. We're looking for the largest, right? Yeah, so result is 0. So we have the prefix or, so we're gonna look into where we say if prefix dot contains pxor, right? If it contains, and then what we're gonna go for int j of at this okay, then what we need to do is minus if I minus j, right? No 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 we'll start from 1. So if this is already smaller or equal to res, okay, then we can quit. So we're never gonna do it. Okay, if I minus j mod 2 is equal to 1, which is odd, that is also not going to work. And also we want equal number of even and odd numbers. Okay, we have one more thing we have to check. So this is a continue, right? So the continue, and we need to know the number of even fork, number of even. So we do have to go through this num evens. Okay, so I do need to say num evens I shall equal to num evens. Not call it prefix num evens. Okay, we have prefix num evens. Prefix num evens I minus 1 plus the current one, which is nums I minus 1 and 1. That's actually not right. Let's be more exclusive. Let's be more explicit. This is the number of evens. Okay. So this is too small, right? This is not even count. Okay, if pref num evens I minus pref num evens j. Okay, this mod of 2 is not equal to 0, we'll continue. Well, actually it's not, it has nothing to do with this. This has to be if this is the number of evens, right, times 2 is not equal to I minus j, right? This is a number count of evens not equal to count of odds. Okay, continue. Otherwise, right, it's too small. Otherwise, the first one we get, right? So we'll break, we'll continue, and the first one we get is going to be, so rest will equal to the first one we get, and we'll break. Because the first one we get is the best. And we'll allow some continues, but if it's smaller, then we just don't allow it. Right, once we're done, then we say pref exclusive or position, p exclusive or, I'll push back I. And then at the end we'll return 0. Now return 0, return rest. Alright, let's take a look, see if this one is right. We're just gonna try this once, and if it doesn't work, then we'll go back to the drawing board. It works. So this one, let's reset everything. Looks to be good. The only concern is the time complexity, but I think in reality these conditions might make it work. Ooh, it does not make it work. So we still have to improve TLE. Okay, that's fine. I mean, we just need to tweak on this. I still think I'm on the right path. It's just this thing kind of not very friendly, even if you jump out early. I do not know. Maybe based on what the result is, we can check if we can get something bigger than the result. That can use binary search, right? We can see if we have something bigger. But if we do, yeah, it still doesn't solve the problem. Alright, I'll fight another day. I'll see you.